Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to start Unit 2. The title of Unit 2 is Theory of Quadratic Equations. Today we'll discuss about the nature of the roots of the quadratic equation. The nature of the roots depends on the expression which is under the radical sign. You know that when we find the solution of a quadratic equation by using the quadratic formula. The quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac over 2a. The expression inside the radical sign, that is b square minus 4ac, decide the nature of the roots of the quadratic equation. Either that root is real. If that is real, it is rational or irrational. And if it is not real, either this is imaginary. So the roots can be real or imaginary. So without solving the quadratic equation, we can find the nature of the roots of the quadratic equation. So this lecture is about the nature of the roots of the quadratic equation. So let's start the lecture. Nature of the roots of the quadratic equation. We know that the roots of the equation a square plus bx plus c is equal to 0. This is the general form of the quadratic equation. When we use the quadratic formula, we have these two roots. The solutions are also known as the roots of that quadratic equation. So you know that this is a first root and this is the second roots of the quadratic equation. And I have told you that the nature of the roots depends on the expression which is inside this radical sign. So this expression is b square minus 4ac, and this expression is known as the discriminant of the quadratic equation. So the nature of the roots depends on the value of the expression b square minus 4ac, which is called the discriminant of the quadratic equation. So we can define as discriminant is equal to b square minus 4ac. So let's start the exercise 2.1. Question number 1. Find the discriminant of the following given quadratic equations. Part 1. 2x square plus 3x minus 1 is equal to 0. You know that this is the standard form of the quadratic equation. So let's start the solution. We know that the coefficient of x square is a, so a is equal to 2. The coefficient of x is b, so b is equal to 3, and the constant value, this is equal to c. So a is equal to b, b is equal to 3, and c is equal to minus 1. And discriminant, we know that this is equal to b square minus 4ac. So now replacing the value of a, b, and c. B is 3, so 3 square minus 4, a is 2, and c is minus 1. So 3 square 9, and 4 2s are 8. So minus minus plus. So 9 plus 8, which is 70. So discriminant of this given quadratic equation is 70. Question 2. Question 1, sorry, part 2. Here a is equal to 6, b is equal to minus 8, and c is equal to 3. We know that discriminant is equal to b square minus 4ac. After replacing the values of b, a, and c, we have discriminant is equal to minus 8. So assignment, Part 3 and 4 are for your assignment. So now we'll discuss the nature of the roots of a quadratic equation through discriminant. If the discriminant is greater than 0, mean discriminant is positive, and this is also a perfect square. Perfect square mean if you find the discriminant, that is 4, 4 can be written as 2 square. So 4 is a perfect square. So if you find the discriminant 16, so 16 can be written as a 4 square, so that discriminant is also a perfect square. If you find that the discriminant is greater than 0, mean discriminant positive and perfect square, then the roots will be real, you can say that rational and unequal. If the discriminant is greater than 0 and a perfect square, then the roots will be rational and unequal. If discriminant b square minus 4ac is greater than 0 but not a perfect square, then the roots will be irrational and unequal. If the roots if if the discriminant b square minus 4ac is equal to 0, then the roots will be rational and equal. If the discriminant b square minus 4ac is less than 0, then the roots will be imaginary and complex conjugate. So without solving the quadratic equation, we can discuss the nature of the roots of that quadratic equation through discriminant. If discriminant is greater than 0 and is a perfect square, then we say that the roots are rational and unequal. If discriminant is greater than 0 but not a perfect square, then the roots will be irrational and unequal. And if the discriminant is equal to 0, then the roots are rational and equal, or you can say that are repeated roots. If discriminant if discriminant is less than 0, then the roots are imaginary or complex conjugate of each other. Exercise 2.1 question 2. Find the nature of the roots of the given quadratic equation and verify the result by solving the equation. So these are questions, part 1, 2, 3, and 4. So part 1, x square minus 23x plus 120 is equal to 0. Solution. Here a is equal to 1, b is equal to minus 23, and c is equal to 120. And discriminant, we know that is b square minus 4ac. After replacing the values of a, b, and c, and we can see here that we have discriminant is 49. So 49 can be written as 7 square, which is greater than 0. So we can say that roots are rational and unequal. Why? Because the discriminant is greater than 0 and perfect square. Since this is perfect square, so the roots are rational and unequal. So the roots are rational and unequal. So now we can verify these roots. So we have to solve this equation and find the solution. So by factorization, we can solve this equation. I'm skipping the detailed explanation of factorization, so which we have discussed in our previous lectures. So just after factorization, we have x is equal to 8 and x is equal to 15. These are the two roots. X is equal to 8. It can be written as 8 by 1, and 15 can be written as 15 by 1. So these two numbers are also rational numbers, and these are unequal. So so it means that roots of these equations are rational and unequal. Part 2, 2x square plus 3x plus 7 is equal to 0. Solution: here a is equal to 2, b is equal to 3, and c is equal to 7. And discriminant is equal to b square minus 4ac. After replacing the values of b, a and c, we have discriminant is equal to minus 47. So minus 47, which is less than 0. So the roots are imaginary and unequal, or you can say that these are complex conjugates of each other. So verification. So now we have to use the quadratic formula. We know that the quadratic formula is equal to x is equal to minus b plus minus square root of b square minus 4ac all divided by 2. After replacing the values of a, b, and c, we have this form: minus 3 plus minus square root of minus 47 over 4. So now you can see here that these here is within square root. Uh, this expression is negative. So to remove this negative, we have to introduce the iota. So we can say that these roots are imaginary. Why? Because we have to involve iota. So the roots of given this given quadratic equations are imaginary and unequal. Part 3, 16x square minus 24x plus 9 is equal to 0. Here a is equal to 16, b is equal to minus 24, and c is equal to 9. Discriminant is equal to b square minus 4ac. After replacing the values and simplification, we have discriminant is equal to 0. It means our roots are rational. And so if the discriminant is equal to 0, the roots are rational and equal, or you can say that repeated roots. Verification. So we know that we can solve this by using quadratic formula. So here a is 16, b is equal to minus 24, and c is equal to 9. After replacing the values in quadratic formula and after simplification, we have root this is 3 by 4. So these are the second root is also 3 by 4. Thus the roots are rational and equal or question number 3. Just 1 minute. For what value of k, the expression k square x square plus 2 into k plus 1 of x plus 4 is a perfect square? So now we have given that this whole expression is a perfect square. So it means that if this expression is a perfect square, it means that roots are repeated, and so discriminant must be equal to 0. So to find the value of k, we have put the discriminant is equal to 0. So let's start the solution. Here a is equal to k square, b is equal to 2 within brackets k plus 1, and c is equal to 4. Discriminant, we know that b square minus 4ac. After replacing the values of discriminant, here we have to open the formula a plus b whole square, and after simplification we have discriminant is equal to minus 12 k square plus 8k plus 4. So now we can take 4 as a common, or now it is given that the given expression is a perfect square. Therefore, the roots are rational and equal. Therefore, discriminant is equal to 0. So we have to put this value is equal to 0. And now we can factorize these two terms. And after factorization, we have 12k plus 4 to k minus 1 is equal to 0. Either 12k plus 4 is equal to 0 or k minus 1 is equal to 0. So 12k is equal to minus 4 or k is equal to minus 4 by 12. So here So we can simplify this. We have k is equal to minus 1 by 3, and here k minus 1 is equal to 0, it means k is equal to 0. So the required values of k are minus 1 by 3 and 1. Question number 4. Find the value of k if the roots of the following equations are equal. So part 1, 2k minus 1 x square plus 3kx plus 3 is equal to 0. Solution. Here a is equal to 2k minus 1, b is equal to 3k, and c is equal to 3. Since the roots are equal, so the discriminant b square minus 4ac must be equal to 0. After replacing the values of a, b, and c, we have this. So now we can take common here 3. So after dividing both sides by 3, we have 3k square minus 8k plus 4 is equal to 0. So now we can factorize these terms. So after factorizing this quadratic equation, we have 3k minus 2 into k minus 2 is equal to 0. Either 3k minus 2 is equal to 0 or k minus 2 is equal to 0. If 3k minus 2 is equal to 0, it means 3k is equal to 2 or k is equal to 2 by 3. If k minus 2 is equal to 0, it means k is equal to 2. So the required values of k are 2 by 3 and 2. Are 2, x square plus 2 into k plus 2, x plus 3k plus 4 is equal to 0. Solution. Here a is equal to 1, b is equal to 2 into k plus 2, and c is equal to 3k plus 4. As the roots are equal, so discriminant must be equal to 0. b square minus 4ac is equal to 0 after replacing the values of a, b, and c, and after simplification we have here 4k square plus 4k is equal to 0. Here we can take 4k as a common, so we left with k plus 1. So either 4k is equal to 0 or k plus 1 is equal to 0. 4, that 4 is not equal to 0, so the only condition is that k is equal to 0. So here k plus 1 is equal to 0, it means k is equal to minus 1. So the required values of k are 0 and minus 1. So assignment, third part is for your assignment. So this is all about this lecture. Inshallah, in next lecture we will discuss the remaining question of exercise 2.1. So Allah Hafiz.